Today, I'm joined by Dr. Sarah Berry, a leading nutrition scientist, nutrition professor at King's College London, and chief scientist at Zoe. She's also the lead nutritional scientist on the Predict program, which is the world's largest in-depth nutritional research program. Today, we're going to talk about the science of ultra-processed foods, why calorie counting should be obsolete, how menopause changes the gut microbiome, and so much more. Dr. Berry, for people who are still locked into a calorie counting mindset of calories in versus calories out, how would you explain the fact that all calories are not created equal?
So I'd explain it in two ways. I'd explain it firstly in the sense of us as human beings, how it actually isn't just a case of calories in and calories out in terms of how we maintain our body weight. And I think this is really important because lots of people that are counting calories, it's because they're trying to either maintain their body weight or lose their body weight. So the first thing I would say is our bodies have evolved to be able to handle times of famine. We have evolved to be able to handle scarcity in food. And so therefore, as soon as we start counting the calories in and the calories out, our body puts in different mechanisms to try and protect us from that weight loss. One is that we increase our feelings of hunger. And so we become even more hungry. And so that drives us to want to eat more. So the natural hunger drive becomes more pronounced. And then also our metabolism changes. We go into a state of being very efficient with our metabolism. So our metabolic rate reduces. So you're feeling more hungry and you're burning less calories. And so that did us well 200, 300, 400, 500 years ago, at times of famine, for example. But when we're in this food environment that is really an obesogenic environment, it doesn't do us very well. And then the second reason I think it's really important is because of the food itself, not just us, but because of the food that we're eating. And that's because you can have foods that have identical ingredients, identical back of pack labeling, but actually can have very different impact in terms of how many calories we extract from them and also how we metabolize them. And we've seen this with my own research. If we take almonds, for example, if we consume whole almonds or we consume finely ground almonds, there's a huge difference of about 30% on average in terms of the amount of calories that we actually absorb, depending on whether they're whole or whether they're ground, with us actually absorbing 30% less calories if they're whole compared to being ground because of the magical food matrix. And we can come on to discuss that in more detail. But then where it gets really interesting is then the intersection between the food and the individual. And if we use the example again of almonds, we see some people are super absorbers. So some people can consume that whole almond and extract an entire 160 calories from a portion of almonds. On average, people will get about 120, 130 calories, but then you get some people that are getting even less than that, that might be getting about 70 calories from that portion of almonds. So you've got 100-calorie difference from one person to another person in terms of how many calories they're actually absorbing or metabolizing, to use the correct word, from that portion of almonds. And so for that person that's getting the whole 160 calories, really what that back of pack labeling is telling them about the calories is something quite different to that person that's only getting, say, 70 calories from that same portion of almonds. And so this is why I think calorie counting is not the best way to maintain a healthy weight or lose weight. Firstly, because we are conditioned to be able to conserve as many calories as possible, but also because depending on the form that the food's in, it can have a very different impact on the amount of calories that we absorb. And then as individuals, some of us will absorb more than others will absorb. And then there's some really basic principles like the inaccuracies in some of the back of pack labeling, and so forth.
Because you can have up to a 20% discrepancy in the back of package labeling by nutritional standards. Is that correct?
Yeah, I don't know the exact percent, but I know that on average, I believe that there's about a 10% discrepancy across different foods in the back of pack labelling calorie information. And when you've got people who are trying to restrict their calories, 10% is actually quite a big amount. You know, if someone's consuming 2,000 calories a day, that 10% is 200 calories, which is a lot.
So I love how nuanced your brain is and the decades of research that you've spent on nutrition and how food impacts your cardiometabolic health and bringing it so much deeper than just what the surface level nutrition advice has been for the last decades, which I think has really done people such a disservice. When you talk about how you wouldn't recommend calorie counting or a calorie focused approach, would you say that you do have to be in a caloric deficit in order to lose weight?
Yeah, absolutely. So that's what I think is important to acknowledge, that, a calorie is a form of energy, and simple physics of calories in and calories out still applies. And so, absolutely, if you are in calorie deficit, you will lose weight. Yes. But I think where I try and de emphasize the importance of calories is because we know that calorie counting for long term weight loss, or rather weight maintenance, just doesn't work. That absolutely calorie deficit, calorie counting can work for that short term weight loss. But there's only so long that most people can fight against these really heightened hunger signals that are driving so much extra appetite. There's only so long as well you can reduce your calorie intake, at that kind of magic sort of set point, so to say, of below which, our metabolism changes. And so this is why the evidence shows very clearly that the majority of people within 5 years actually put on most of the weight that they lose when they lose weight through calorie counting. And this is where exercise becomes quite important. What we know is that the evidence shows that during that initial weight loss phase, that calorie counting, calorie deficit is really important. But in order to maintain that weight loss, that's where exercise becomes quite important. But I think that the totality of the evidence shows that to lose weight and maintain weight loss, you need to do it slowly, which I know can be not as satisfying for someone that's maybe losing weight because not just their health, they might want to fit into their wedding dress or that bikini in the summer. But the slow weight loss is the weight loss that you are more likely to maintain. But weight loss that's achieved through actually just focusing on eating more healthily rather than calorie counting, again, is the kind of weight loss that's going to be maintained, because you'd be focusing on eating the types of foods that keep you fuller for longer, that activate your fullness signals, and so forth.
So it doesn't have to be a calorie counting obsession. It's more about eating the foods that keep you more satiated so that you're naturally decreasing your caloric intake to be in a slight caloric deficit so that it creates slower weight loss over time that becomes more sustainable.
Absolutely. And, to counterbalance that is also on the counter argument, is as well as what you've just described, is trying to avoid the kind of foods that are going to encourage us to overeat. And so we've done research where we've shown that if you consume, for example, a white bagel on its own, or white bread on its own, what happens is that whilst you might be consuming something that on the face of it is low calorie, because you're just consuming, maybe 100 grams of carbohydrates, but you get this short rise in circulating blood glucose that then dips 2 to 4 hours after. And you actually go on to consume, on average, if you have a dip at breakfast like that from consuming just carbohydrates, about 300 calories more than if you were to have with that carbohydrate some additional protein or some additional fat. And we've done this research where we've asked people on one day to have a bagel or toast on its own or with low fat spread. And then we've asked them to come in the next day, and the next day, in this is done actually in random order, but on the other occasion to add either cheese, which is high in protein and fat, or to add in a nut butter, which is high in protein, fat, and fiber. So they're adding extra calories at their breakfast, but actually that prevents that blood sugar dip. It prevents that feeling of hunger that you get when you have that blood sugar dip. And actually, it means that over the day, although they're having more calories at breakfast, they go on to consume less food over the duration of the day because they're having a more balanced blood sugar. They're not getting these like hangry hunger signals driving them to get that quick fix. And so I think that really shows how often opting for low calorie foods, which often involves low fat foods, actually is totally counterproductive, because all that happens is you feel more hungry later in the day and you go on to consume more.
I love all of the work that you do. I am just such a fan of all of the nutrition science that you've put out and how you've legitimized so many of these principles of eating whole foods and caring about blood sugar balance and thinking more in depth about foods than just the surface level of how many calories they have, because you are one of the leading nutrition researchers in the world. And the fact that you have these research trials, these research studies like you're talking about, this in particular, I remember when it came out a few years ago and sharing it within my nutrition programs because of how significant it is, that it's about thinking about how blood sugar impacts that increase in hunger that you can have, the hunger and the cravings that happen when you're on that blood sugar roller coaster throughout the whole day. Can you zoom out for a second and explain in a basic way how this works mechanistically?
Yeah, so when you consume a carbohydrate rich meal, what happens is you have a short term increase in circulating blood glucose. It typically peaks around 15 to 30 minutes after consuming the meal. This is what everyone seems to be fixated on, these blood sugar spikes. Oh my God, they're going to kill us. No, they're not. That's a normal physiological response to consuming carbohydrates, to have an increase in circulating blood glucose. We do not need to flatline. Despite what you hear from some influencers, it's absolutely normal to have these increases in circulating blood glucose. What we don't want to do is have really big, so excessive peaks day in, day out. And one of the reasons we don't want to do that is because quite often what can happen is you can have what we call an overshoot in insulin, which causes a blood sugar dip a couple of hours later. So when you consume that carbohydrate, as your blood sugar increases, so your blood glucose increases in your blood, you release a hormone called insulin, and insulin's role is to remove the glucose and put it where it should go in the body, whether it's the muscles, liver, and so forth. And what you can sometimes have is what we call an overshoot in insulin. So you're releasing a bit too much insulin, which causes then you to have actually a dip in circulating blood glucose that goes below your normal baseline values. Now, it's not a dip to the extent that a type 1 or type 2 diabetic might experience, where they're going into a very dangerous hypoglycemic dip, but it is a dip that still affects us physiologically. And when you have this dip, it typically occurs 2 to 4 hours after consuming carbohydrate, particularly if you're consuming it on its own without fat, protein, or fiber. And what our research has shown is that this dip causes this feeling of hunger. It also reduces your feeling of energy. It reduces your feeling of alertness. And people who have this dip go on to consume their next meal 30 minutes sooner. They go on to consume about 100 calories more at their next meal and go on to consume 320 calories more over the day. But where I think it gets really interesting, and kind of it brings it back to you as an individual, is when we've done studies where we've intentionally given someone a breakfast that we know will cause them to have a dip, so that high carbohydrate, that bagel or that white bread. And then the next day we say, okay, come back and we want you to have a breakfast that isn't going to cause you to have a dip. So it might be matched in carbohydrates, but have that extra protein, fat, or fiber. What we see is if you have a breakfast that doesn't cause you to have a dip, you go on to consume less calories that day than when you have the breakfast that causes you to have that dip, because you're not going on that roller coaster. And it's those dips that I think we don't talk about enough, that we're so preoccupied with these glucose spikes, that actually it's the dips that are driving excess calorie intake that cause us and some people to feel, hangry, and, some people feel shaky, some people get brain fog during that period. We all talk about the post-lunch slump. Well, actually, for most people, it's because they're having this small dip in circulating blood glucose. Some people it doesn't affect, some people never seem to get them, but we see a large proportion do actually experience these.
And then that's when they're jumping to the pick me up, the caffeine, or that next, like you're talking about, the meal or the snack that's happening sooner, or the sugar that they're trying to like pick up their energy. And I'd be interested because I run a program called the Blood Sugar Reset that we've had 25,000 people go through, and the top 3 symptom improvements that we see are improvements in energy, mood, and cravings with stabilizing blood sugar. Is that what your research shows also, or is it different in the symptom improvements?
Absolutely. We haven't looked at cravings per se, but what our research shows is absolutely those dips are associated with reduction in alertness, increases in calorie intake, reduction in feelings of energy, and also reductions in your mood. So, poor mood. So if you can stabilize that, then, it would stand to reason that, yes, you would also see those improvements, and that's why I think it's really important that we don't just think about the spike, we think about what's happening with the dip, and that we make sure we just go back to simple healthy eating principles where we're not buying all of these low fat, meals, or, where we just make sure we build simple balanced meals that have some carbohydrate, have some protein, have some fiber, and have some healthy fats in them.
Hmm. And like you said, that you don't have to eat extremely low carb in order to balance your blood sugar. Is that also what your research shows?
Absolutely. So we have quite a few different research studies around this. Some of them aren't all published. One of the ones that isn't published is where we give a 50-gram available carbohydrate load, and then we overlay it with whether it's protein, fiber, or healthy fats. And what we see is as soon as you start overlaying it, so bringing in some healthy fats, protein, or fiber, that absolutely that balances out your blood glucose, your blood sugar levels. So, absolutely, I don't believe that we should be demonizing carbohydrates. I do believe that we consume too much refined carbohydrates like white bread, white rice, white pasta. But I think that as long as we're consuming that with healthy oils, with vegetables, fiber, etc., it can be part of a really healthy, balanced diet. We don't need to strip carbohydrates from our diet. And actually, carbohydrates are a really important source of fiber. If we're opting for whole grain varieties, that's such an important source of so many different nutrients.
Yes, yes. I love it. Okay, so let's talk about the food matrix. I think that this pairs nicely with how you explain the food matrix. Can you share more about that?
Yeah, absolutely. So the food matrix, really simply put, is the structure of our food. And it's something we don't think about enough. And yet it's something that's so important, I think, and relevant to the food that we're eating now, given that so much of our food is processed, and processing changes this structure of the food or the food matrix. So when we think about how food impacts our health, typically we think about the nutrients, fiber, fat, protein, or carbohydrate. That's how historically, as nutrition scientists, we've thought about a food. Is it saturated fat? Is it monounsaturated fat? How much is sugar? How much is fiber? But what we now know is, secondly, that there's also thousands of other chemicals we need to be thinking about when we think about the healthfulness of a food. So we know on average a food contains about 50,000 chemicals. Many of these have really powerful impacts on our health. So you might have heard of polyphenols, for example, which have these bioactive like properties, acting on anti-inflammatory pathways. So you have all of these thousands of chemicals, you have the core nutrients that we've talked about typically, but these are encapsulated within a food structure, whether it's within a grain, whether it's within a nut, a seed, an apple, and so forth. And what we know is that if you change the structure of the food, you actually change many features related to the healthfulness of a food. You change how much calories you absorb from that food, you change where you digest that food, and you change how quickly you digest that food. And we've seen this through my own clinical trials that I've been running over the last 15 years or so at King's College London, where we feed people, for example, large porridge. If we feed them large porridge, so imagine kind of the large porridge flakes, or on another occasion, we feed them exactly the same porridge, but we just grind it. So we just put it in a blender. But the back of pack labeling would be identical. The ingredients would be identical. The nutrients would be identical. But how we metabolize it is very different. So we see, for example, if you have the finely ground porridge, you have a 50% higher post-meal glucose response. So 50% higher peak in that circulating blood glucose or postprandial glycemic response. We see differences in gut hormones, in fullness, in hunger, and so forth. And yet you've got two foods that would, in a supermarket, have the same ingredients, the same back of pack labeling. All you've done is change the structure. You've just broken down the integrity of that plant, of the cell walls. We see the same with almonds. And this is something I know I talk about a lot, and we've already mentioned. So we've done studies where we feed people whole almonds, or we get those almonds and we just grind them down. You see a 30% difference in the calories that are absorbed. You also see a huge difference in the postprandial lipemic response, which basically refers to the increase in circulating fat following consumption of the almonds. So you see about a 50% lower circulating blood fat response, so postprandial lipemic response, after having the whole almonds versus the ground almonds. Why is this? It's really simple. You're just breaking down the structure. So if we take nuts, for example, we know that nuts, whether it's walnuts, almonds, etc., the size of the particles are tiny. So within a nut, the point at which you're swallowing it, we know that you swallow a nut at about 1 millimeter particle size. And we've done these chew and spit studies where we actually say to people, right, the point at which you're about to swallow that nut, can you spit it out? And then we measure the size. We don't sit there with a ruler. We do have fancy equipment that we do this with. Um, and we know that you swallow on average at about a 1 millimeter particle size. Now, within that 1 millimeter particle, are hundreds and hundreds of intact nut cells. And these cells are basically encapsulated by, you have the cell wall, which essentially is fiber. And what they're doing is encapsulating the other nutrients. It's encapsulating the fat from the almond. So as they pass through the gastrointestinal tract, you've got these 1 millimeter particles. Some of them are being broken down. So some of the cell walls are being broken down and some of the fat is released, but you have a lot of intact cells reaching your large intestine. This is good because it's feeding your gut microbiome. If you're wanting to watch your energy intake, it's also good because you're excreting 30% of the calories. You're lowering also your post-meal, your postprandial lipemic response, your post-meal blood fat response. Yet, if I was to feed someone those whole almonds or those ground almonds, but look at the back of pack labeling, it wouldn't say, oh, there's a 30% calorie difference, or you're going to have this different metabolic response, or you're going to have different feelings of fullness and hunger. No, they're the same food. All you've changed is the structure of the food. And I think it's so relevant because so much of the food that we eat now is processed in such a way that it changes the structure and therefore it changes how we respond to it. And Brigid, there's one of my favourite studies that I think really illustrates this is a study that was actually conducted in 1977. It was by this guy called Haber, and it was published in The Lancet. I think it's one of the first nutrition studies ever published in The Lancet. And he fed individuals whole apples, apple puree. So he just got the apples and pureed it. Again, identical back of pack ingredients, or apple juice, so he had actually taken out the fiber. So it was just the juice left. And what he found was that firstly, there was a huge difference in the speed at which they ate the set amount of calories. So I think it was 50 grams of available carbohydrate from either the whole apples, the apple puree, or the apple juice. And there was a big difference in the speed at which they consumed. It was about a 5-fold difference. So the whole apples were eaten a lot more slowly than the apple puree, which was eaten more slowly than the apple juice. And there were big differences in how full people felt, in their glucose responses and dips and so forth. So then they invited the people to come back and they said, okay, we want to repeat this, but we want to hold steady the speed at which you're eating. So we want you to eat the whole apples and the apple puree and the apple juice at exactly the same speed. Even when they did that and they controlled for that rate of eating, they still saw a huge difference in people's feeling of fullness. They felt so much more full from the whole apple compared to the apple puree, and even more so compared to the juice. And this is simply because of the structural integrity of the whole apple versus the puree. Where it gets really interesting is that what we also saw is the apple puree and the apple juice also caused quite a big dip in blood glucose 2 hours after consuming them, and yet you didn't see that in the whole apple. So you've got foods that you're eating at the same rate, you're experiencing differences in fullness and hunger throughout the whole test period, and then when you're having the whole apple, you're not getting this unfavorable dip also in blood glucose that we know goes, makes you go on to consume even more.
It's so fascinating. So the message and the takeaway is that different structures of the same food will create different responses in the body. That's not to say that people should be scared to eat almond flour, for instance, something that contains almond flour versus almonds, because I do believe that, almond flour could be a much better substitute than something like refined grains. But that if you have the option to do something that's like a baked good with almond flour or the whole almonds, opt for the whole almonds. Is that the takeaway?
Yeah, I think that it's a double-edged sword as well. So you've got to remember not everyone needs to be watching their calorie intake. And also by excreting some of the almonds, you're also excreting some of the wonderful vitamin E and other beneficial chemicals that are trapped in those cell walls. And I think absolutely any plant food you should be consuming, whether it's ground or in its original structure. So if the only way you're going to consume apples is by having an apple smoothie or apple puree, well, that's far better than not having it at all. But given the choice, try where possible to eat the food within the original structure within which it was created.
And then it brings me to the idea of smoothies. So I do like a lot of smoothies in my nutrition plans that have typically at the base of them water with cauliflower rice, frozen cauliflower rice, and that adds a lot of thickness to it. It's more like from a texture standpoint that I like to add the cauliflower rice, and then some like a half a cup of frozen berries and some nut butter or chia seeds or some kind of seed. And then protein powder. So I'm interested in, because I personally, when I'm wearing a continuous glucose monitor, don't see, large increases in my blood sugar. But what do you think the takeaway is for making a smoothie like that?
So I think what you've just explained really nicely transitions from what is shown in the lab and is scientifically interesting to actually what's the application. So while scientifically, absolutely, the evidence shows eating those berries, those apples, those whatever in the original structure, not smoothieing them, is better for your blood glucose. In practice, actually, if we build a balanced smoothie, it really doesn't matter. And so, what you've described as a smoothie that also has healthy oils, because you've got the nut butter, also has some protein because you've got the protein powder, but more importantly, the protein that's in the nut butter, the fiber as well from the nut butter. So, all of that is going to counteract any small negative effect that you would get from smoothing, from blending up that fruit. So, in my opinion, what you've just described is still an incredibly healthy smoothie. I think it's when you're just consuming that fruit in isolation without having some protein, some fat sources, that you're more likely to get these kind of big peaks followed by these big dips and be on this roller coaster. So it's where you get people that are saying, oh, I have, two apples, a carton of strawberries, and three oranges, and I put them all in the blender and I've had my 5 a day, my 5 portions of fruit for the day, I'm done. Yeah, that's great. You'll be getting loads of vitamins, loads of fiber, but actually you're probably very likely to have that dip in glucose. But if you're building a more balanced smoothie, which is what you've described, then I think it really doesn't matter if you're blending up that fruit.
Okay, great. Yeah, that's very helpful. And then when you're saying though that fullness, sometimes I do hear people say that they don't feel as full drinking a smoothie compared to eating a meal. And so I'll often ask the question, make sure that it's actually hunger and that it's not an innate desire to chew, because sometimes, when you have a smoothie, it's like you just want to be able to chew something as well. What do you feel like that could be impacting the fullness from drinking a smoothie because of what you're explaining?
Yeah, it could be. I mean, there's a lot of research around texture now and how the texture of food changes our how we chew the food, our perception of fullness, satiety, and the rate at which we also eat the food. So, what would be interesting is knowing how fast these people are also drinking their smoothie, because I think this is something that's really important, again, related to the food matrix, because what we know is when you destroy the food matrix, you tend to soften the food. So it tends to become a softer textured food. What we know is if the food is a softer texture, just like that apple puree, you consume it a lot more quickly. So it's easy to drink the kind of smoothie that you said and get that many calories in a lot shorter period of time than if you were to have those nutrients from some of the whole foods that they came from in the first place. What we know is if you eat really quickly, so if you have soft textured food, you eat it very quickly and you don't experience the same level of fullness compared to if you ate that more slowly. It takes a little bit of time for the fullness signals to go from our gut, particularly our lower gut, to our brain to say, hey, I'm full, you don't need to eat anymore. And this is why we know that eating rate is actually really important in relation to food structure, texture, but also in relation to the food that's on our shelves now. That so many processed foods that are on our shelves now are actually very soft in their texture. So it's very easy to eat them very quickly and therefore overconsume them.
Makes so much sense. And I think it takes us to another principle that you talk about, which is how we eat and paying attention, being in tune with how we eat, mattering just as much as what we eat. Can you talk about what that means?
Yeah, this is an area that I think we don't talk enough about in nutritional science. We've been so focused on what you eat and calories and nutrients and more recently ultra processed food and yet actually how we eat is so important. And how we eat now is so different to how we ate 100 years ago. And how we eat is partly determined by our behaviors because of our busy lives, but also by the food that we're eating. And by how we eat, I mean factors like how fast we eat our food. I mean the time of day that we eat our food. I mean the fasting period that we eat in and the consistency within which we eat our food. So, what we know is that the rate at which we eat our food, so the speed that we eat our food, is really important. And many of the foods that have been processed to be softer textured, we tend to consume a lot more quickly. So, we tend to consume more of them. And there's been some lovely research that's come out of Kieran Ford's group in the Netherlands, where they've done lots of clinical trials where they've tried to modify the texture of food in order to change the speed at which people eat the food. And what they see from this is if you can slow down the speed that you eat your food by just about 20%, you can reduce subconsciously, without even thinking about it, your calorie intake by 15%. So, what does that mean? Well, instead of having your lunch over 15 minutes, if you can have it over 18 minutes, then on average, people will eat 15% less calories just from slowing down. We all eat our food fast. We're distracted because we're watching TV or we're on a Zoom call while we're eating, or we're rushing between meetings or we're eating it on a go. So I think that's a really great example of just slowing down how fast you eat your food. We can all do this. We don't need fancy tests. We don't need to have fancy blood tests done. When you sit at the table, most people know, are they a fast eater or a slow eater? I know when I sit with my family, my husband and my daughter guzzle down their food so fast. My son and I eat at a nice normal rate, I think. And so just think, okay, can I slow it down? And I don't mean to sit there for an hour, just slow it down. Allow time for your hunger, fullness signals to come into play. Then we know that the time of day that we eat our food matters as well. So we're more insulin sensitive in the morning. We know that from research, if you're eating later in the day, you tend to have a different blood sugar response, so a different glycemic response compared to in the morning, that it's more favorable in the morning. That cake in the morning you'll have a more favorable blood glucose response compared to having that cake later in the day. We also know from a recent trial that if you're consuming calories later in the day, you tend to actually wake up more hungry in the morning compared to if you're having exactly the same meals and calories, but slightly shifted earlier in the day. So it's kind of counterintuitive. So by having that late snack, actually you're going to wake up on average hungrier the next day. And then in addition to this, we know that how you metabolize the food is different, but your perception of hunger and fullness is different. And there's been trials looking at if you feed people the same food in the afternoon compared to the morning, how does that impact your hunger and your fullness signals? And so that same food later in the day doesn't stimulate as much fullness as having that food earlier in the day. And so it's less satiating, it's less filling than if you're having it earlier in the day. And so all of that evidence points to us trying to have a bigger breakfast, bigger lunch, and a smaller evening meal, and to try and avoid snacking, ideally after 8 or 9 o'clock in the evening. And it's interesting because if you look at how people's calories are staggered throughout the day in the UK, in the US, most people have the majority of their calories later in the day, with their main calorie meal being in the evening. But if you look in these very healthy Mediterranean countries, you see that actually their breakfast and their lunch are their biggest eating events. So where they have the majority of their calories. And whilst they might eat quite late in the evening, actually it's the smallest meal of the day. Then two other factors that I think are really important around how we eat is having a fast period. So I know that time restricted eating has become quite popular with many people. And basically, what we need to do is give our body a rest. So every cell in our body has its own little body clock. Our gut microbiome does as well. We all need to give those cells and our microbiome a rest. If we are constantly eating and eating late into the night and early in the morning, we're not giving these cells, our metabolism, a rest. And our research shows that just reducing your eating window, so the period from when you have your first meal to your last meal, down to 10 hours a day, can actually significantly benefit your health. And so I think this is something else we can do around how we eat. There's some very restrictive protocols about time restricted eating where people say, oh, yeah, I'm eating in a 6-hour window. Well, fine if that works for you, but I think that must be blimmin' boring. That, I opt to have my first meal at 10 o'clock and my last meal at 4 o'clock in the afternoon personally. And our research shows, even 10 hours, you still get a good benefit. And then, Brigid, if we've got time, I'd love to say one more thing to do with how we eat as well. And this is something that's quite newly emerging research. It's not by my group, it's by some other researchers that have been looking at consistency of eating. And just like we know consistency of sleeping is important, and we've done research looking at what we call social jet lag that shows that if you have an inconsistent sleeping pattern, it's not good for you. We now are also starting to see some data emerging to show that a consistent pattern of eating is important. Our bodies like predictability. And so there's some interesting research where they've had people either following an erratic eating pattern where they might have one day 2 big meals, another day exactly the same energy and calories, but spread across 6 meals, and then the other day 3 meals and so forth. Or they have individuals having just kind of a set amount of, 3 main meals, or having multiple eating events, but that are consistent. And what this evidence shows is that health outcomes improve if you're having a consistent pattern of eating. So if you typically like just 3 main meals a day, try and be consistent with that. If, like me, you're a grazer, so I do snack quite a lot throughout the day, that's fine as long as you're consistent. Where it seems that there's problems is where you have people that might be like, oh, I'm having a really good day, I'm just having breakfast and lunch. Then the next day they're like, oh my gosh, it's all gone to pot. I'm having breakfast, lunch, dinner, 5 snacks. Oh, and then the next day they're like, oh, I feel so bad, I'm just going to have 2 meals again today. So consistency also seems to matter. So that's slow down how fast you eat your food. Try and avoid having your main meal too late in the day. Try and avoid eating after 9 o'clock. Try and be consistent in the pattern that you're eating, and try and have a 12 or 14-hour period where you're not eating overnight.
So beautiful. And when we're talking about how we eat, I feel like there's one other element that is talked about a lot, which is the order in which you eat. How
Yep.
much evidence is behind the order of eating?
So there is a reasonable amount of evidence to show that the order in which you eat can impact certainly your blood glucose levels. And can impact your fullness and your hunger as well. So what we know is that if you have protein, fat, or fiber prior to having carbohydrates, and ideally about 15 minutes before the carbohydrates, that can significantly reduce your post-meal glucose response. It delays gastric emptying, so it slows down the rate at which your stomach empties, so you have glucose appearing more slowly in the bloodstream. The protein also stimulates insulin, so as the glucose is appearing going in the bloodstream is being removed by the insulin. Fat and protein and fiber can stimulate other gut hormones involved in your fullness, perception of fullness as well, as hormones involved in how you digest and metabolize that carbohydrate. So, yes, there's evidence to show preloading, as we call it, so 10 to 15 minutes or even 30 minutes in some cases for protein, can significantly reduce your post-meal glucose response and can favorably affect your feelings of fullness and hunger. However, I think as a strategy, I personally wouldn't recommend it because I think it's kind of taking this whole biohacking, in my opinion, a bit of a step too far, because I don't want to, when I sit down to have my lunch, think, oh gosh, okay, let me put the timer on and let me just take this part of the meal. Oh, and then let me come back 10 minutes later to this part that's gone cold and probably squidgy or whatever. I just want to enjoy my meal. I want to enjoy my lasagna. I don't want to pick apart the different bits. I want to enjoy that with my garlic bread and have it all in one go. And so, yes, it does have an impact, but it's quite a small size effect. And I would just say to the person, just slow down how fast you're eating that food. Maybe have a slightly more veg in that meal than you have of the carbohydrate. That will have just as big an effect, yet you'll still get to enjoy the pleasure of that food in the way that I think a meal should be eaten.
Yes, and I love how you're able to take what you know from a research standpoint, but then be able to apply it to real life scenarios to say we shouldn't get so extreme where we're hyper fixated on doing things in an experimental way or a scientific way and make every aspect of our lives so rigid and scientific, but allowing ourselves to actually enjoy the experience of eating and have pleasure in it and enjoyment and have a really healthy relationship with food, which is such a core part of nutrition that I think so many people miss.
Absolutely. I think food is there to bring us joy. Yes, it's there to nourish us. But one thing that we are fortunate in today's society, whilst there is too much food and too much bad food out there, for many of us, I recognize not all of us, but for many of us, food is there all as well as to nourish us, to bring us that pleasure. It's part of our culture, it's part of our social interactions. And I think it's a pretty sad state of affairs if you're sitting at the dinner table and, you're all kind of timing when you have this bit of the food and when you have that bit of the food. And it's like, just enjoy it. I think, we sweat the small stuff and this whole area of biohacking. I think what we've got to remember is what is the size effect? So, how important is, for example, the meal ordering or the time that you're eating the food versus actually just adding in a little bit more fiber to that meal and maybe taking out a bit of that rice from that meal, for example. And I think it's about thinking about your own pleasure, but also, yes, the size effect. And you make a really important point that obviously I'm fascinated by all of my clinical trials and all of the findings around, the food matrix XYZ. But actually, we've got to put things into real life. And it's very easy, when you see influencers talking about this latest study and what it means. Well, actually, what does it really mean for you and how much of an impact is it really going to have on your health? Is it worth the pain or the deprivation, depriving yourself of something for the benefit? In most instances, I don't think it is.
I completely agree. And I think that for people who are just starting out on their eating journey or their nutrition journey, let's say, because everyone, has been on an eating journey for the duration of their lives, but on their nutrition journey where they're becoming more conscious of nutrition and they feel like a little overwhelmed by it, or they feel like, oh, this has to be such a deprived way of living. I think that, as you adjust to this way where you're limiting the refined carbohydrates and the added sugars, that you start to then crave those healthier foods and
Yeah.
you experiment with foods that actually taste more nutritious so that it doesn't end up being something that people often perceive, which is this very vanilla way of living.
Yeah, absolutely. I mean, I was brought up where people would talk about salads as, rabbit food. I'm a child from the 70s where no one had really heard of pasta and you didn't have salads. And the only way to have a proper meal was meat, potato, and two veg. And I remember my father being horrified that my mother dared to cook some pasta or do just a salad for dinner. um, and so there's also that kind of how you've perceived food all your life, changing from that what you perceive to be a meal, as well as changing your taste buds. And, salt's a great example where you have to go through almost a very short period of adjustment for your taste buds to realize you don't need all of that salt. So your taste buds become adjusted to the high salt intake. If you actually reduce your salt intake, after a couple of weeks, you stop noticing it. And then when you start adding the salt back in, it's actually very, very strong. And so, we adjust in our perceptions and also our taste perception as well.
So true. I remember even working with someone who was doing a no sugar diet that we had recommended alongside his doctor that I was working with at the time. And he was saying how he always had to put sugar on strawberries, and how after just that first week, he no longer needed to put sugar on the strawberries because he could actually taste the sweetness of the strawberries. How much time does it take for your taste buds to actually change in that way? Is there research to show how long that takes?
There is, and I don't remember is the answer to that. It's not something that I've actively researched, so or it's an area of my expertise, so I'm not up to speed with all of the research. My recollection is it's probably a couple of weeks, if that, but I don't want to say for sure.
And then there is research showing that your gut microbiome can change in just 3 days of changing your nutrition. Is that right?
Yeah, so there's some research that was actually conducted by one of my PhD students looking at how quickly your gut microbiome changes. And they saw that, yes, within 3 days, you can see a notable difference in gut microbiome, but it's actually changing continuously throughout the day. It's changing depending on the time of day. So our gut microbiome has its own circadian rhythm, so its own body clock as well. It's changing as and when we're eating a meal. But you see notable differences after 3 days. A lot of clinical trials, we would typically have a duration of 4 to 6 weeks to see a more long lasting change in the gut microbiome. But it's very what we call plastic, it's very changeable. And I think this is what's great is that so many intermediary risk factors for health and so many markers, depending on what you want to call the gut microbiome, change very quickly. If you change your diet, our study shows that if you have high cholesterol and you change your diet in such a way that is able to reduce cholesterol, you see a change in 10 days to 2 weeks. You see a change in blood pressure when you change your diet to a diet that's favorable in terms of blood pressure in as little as 4 weeks. And so you don't need to change your diet for a long time to start to see differences in actually health measures and your microbiome, but also how you feel in the here and now. And I think that's where it gets really fascinating. Again, we've talked about blood sugar and mood and energy. You can even feel on that day how food impacts how you feel as well.
And is that because of the fact that the microbiome is the epicenter of our health and at the base of all of the other reactions that are happening mechanistically?
So we know that the microbiome has a really important role to play in our health. I think it's fundamental for our health, and I think we're only just scratching the surface of understanding how the microbiome interacts and mediates how a food impacts our health. I don't think everything is mediated through the microbiome. So we know that, yes, food can directly impact, for example, our cholesterol levels by directly affecting our LDL receptor, or it can impact our cholesterol levels through the microbiome as well. So, whilst I think the microbiome is a really important focus, there's also lots of other mechanisms that are independent to the microbiome, how food impacts our health. But at the end of the day, the microbiome, is considered another organ now. It's this whole ecosystem and what keeps this ecosystem going, what's feeding it, is the food that we eat. And therefore, that's shaping what kind of species we have there, what kind of products and chemicals they produce. And it's these chemicals that they produce that go on to have so many wide reaching effects all over our body.
When I talk about nutrition, I often, create kind of a triangle of saying that three of the core mechanisms for underlying chronic disease and autoimmune disease and hormone dysregulations is really the gut microbiome, insulin resistance, and chronic inflammation. Would you agree with that? Would you add anything to that? And could you explain like how the three of those are so interconnected?
I would say that there's a lot of bidirectionality there, that they're all interconnected. I would agree that chronic inflammation is what is underpinning many of the chronic diseases that we have. We know that the microbiome can impact chronic inflammation. We know that chronic inflammation can impact insulin resistance, and we know that insulin resistance can impact chronic inflammation. Um, I don't know what else I would add to that. That's a tough question. That is a tough. Um, I'm not sure. Do you know what? When I'm lying in bed later tonight, I'll be like, damn it, this is what I should have said.
Yeah, that's fine. We can just move on and
I'm fine saying I don't know. I think that the best experts are the ones that recognize what they don't know. My dad always brought me up with the saying that the more you know, the less you think you know. And I actually feel I know so little about nutrition and nutrition science. So I'm hoping that means that I do know a little bit. But
100%.
it's
I felt
nutrition.
like that so much in functional medicine. Like when I started working for Dr. Hyman and doing my advanced practitioner training through the Institute for Functional Medicine, it's so humbling when it is. I said it all the time. The more you know, the more you don't. You realize that you do not know.
Absolutely. And I think, nutrition is such a broad discipline. You can't know everything. And I think this is where you have the big difference between research active scientists like myself. There's some areas I know in incredible detail. I know quite a bit superficially, but there's lots of areas that I don't know even in a reasonable detail because it's just not possible for me to hold all of that here or to have studied it all.
And one of the limitations with research is that every individual is unique, which I know you obviously have done a lot of work around as well, even trying to identify some of those individualities within each person and their blood sugar response and their postprandial fat response because of all of the differences within our gut microbiomes and insulin sensitivity and predispositions genetically and all the factors that make us each such complex, unique individuals.
Yeah, absolutely. Something that I've been really privileged to be leading over the last 8 years is our Predict program of research. And this is, as you said at the beginning, the world's largest nutrition program of work. We now have data on over 300,000 people where we've been looking at their gut microbiome, their blood sugar responses, their blood fat responses. In sub studies, we've been looking at things like their inflammatory responses. We've been looking at how they eat as well, looking at time of day that people are eating, their eating frequency, how many snacks they have throughout the day, their eating windows, their eating speed, and trying to put all of this together and look at it and look at, okay, what matters and for whom. And it's a fascinating area. This whole world of personalized nutrition is exploding. And I think what we've got to recognize in personalized nutrition is what underpins a healthy diet for one person underpins a healthy diet for everyone. We should all be eating more fiber. We should all be having a greater diversity of unprocessed whole foods, plant-based foods, etc. But there are some differences. And I think that, yes, we know the microbiome is important. Yes, genetics plays a role, although I don't think in any way near as important as the microbiome. Other factors related to who we are is important, like your menopause status, your age, your sex, and so forth. But I think that my journey in personalized nutrition and looking at this huge variability in responses to food that we see is the most exciting finding I think that we've come across is this importance of how we eat and how actually personalizing on how we eat. So the time of day that I might typically eat something versus you might, or how fast I might eat something versus you might. I think that's an area of personalized nutrition that we don't think about enough. We're so focused on what we eat and who we are. But I think how we eat is really important as well.
Yes, it's such an important point. Okay, so let's go on to something that you are an absolute expert on, which is changes in the gut microbiome that occur after menopause, which your research was the first to show these changes. Can you explain what this paper showed and the takeaways for women that are going through menopause or maybe are in their perimenopause years leading up to those changes.
Yeah, so I'd say it's quite early stages of research and difficult to give kind of quite prescriptive advice based on this research. But we conducted a study looking at multiple health features in women who were pre, peri, or postmenopausal. So this was looking at health rather than symptoms, because when you go through the menopause, obviously we know that you have incredible symptom burden, whether it's brain fog, hot flashes, and so forth. But what we also know is your health parameters change. So what happens is when you hit peri and postmenopause, when your estrogen levels decline, suddenly women who are doing very well compared to age-matched males in terms of blood pressure, in cholesterol, in inflammation, in terms of blood sugar responses post-meal, suddenly they hit the peri and postmenopause, and actually their blood pressure, their inflammatory levels, their postprandial, their post-meal glucose responses, their cholesterol levels suddenly go up, and often to meet the level of a similar aged male. And this is because the role that estrogen has in all of the cells in our body. And so we looked at those differences, and we looked at how suddenly peri and postmenopausal women have these increases in these intermediary risk factors for long-term health, like blood pressure, cholesterol, inflammation, and blood glucose responses. And then we went on to have a look as, well, hold on, is there something happening at the level of the microbiome as well? And so in these thousands of individuals, we also had poo samples so we could look at their microbiome. And we found that peri and postmenopausal women had a different microbiome composition to men. And this has been shown in a previous study where they did look at males versus females that were premenopausal versus postmenopausal. And what in this previous study, this was, I think, done about 8 years ago, they found the postmenopausal women had a microbiome composition that was very similar to a male's microbiome composition, and premenopausal women's had quite a unique composition. And so that's why we wanted to have a look at this, because that kind of told us something interesting was going on there. And what we found was that post and perimenopausal women had a greater prevalence of certain species. And these were species that our previous research has shown is associated with greater levels of inflammation and other intermediary risk factors like blood pressure and cholesterol. Yet the premenopausal women had a lower prevalence of these symptoms. Now, why and what's happening, we don't know for sure. And this is something we're doing a real deep dive. Now that we have this data in 300,000 people, we can do a deep dive to see what's happening and why we're seeing these differences. We do know that the microbiome is involved in metabolizing estrogen. And we know that estrogen, it has a bidirectional relationship with the microbiome, that the estrogen also impacts the microbiome composition. And I think that an example I often give of the importance of the microbiome in terms of menopause and how it interacts with food and health and individual variation comes from some research that's looked at the impact of soy isoflavones on menopause symptoms. So it's a little bit different to the research that I just mentioned, but I think for menopausal women listening, I think this is a lovely way of showing how one supplement that their friend might take for menopause might work for them, but might not necessarily work for you. So we know that soy isoflavones contain chemicals which we call phytoestrogens. These are chemicals that mimic estrogen, and so they bind to the estrogen receptor. So if you consume soy isoflavones, you're essentially consuming these phytoestrogens that bind to the estrogen receptor and can reduce your menopause symptoms. But what we know is that some people, when they supplement themselves with soy isoflavones, have a big reduction in menopause symptoms compared to other people who might only have a small reduction in menopause symptoms. And the reason for this is the gut microbiome. And so some people have species that enable them to convert these soy isoflavones from quite an inactive phytoestrogen to a really active one that binds really strongly to the estrogen receptor. And these people are called equal producers. And yet you have other people that don't have those particular species, so they can't convert it into this really strong kind of sort of phytoestrogen. And so I could take a soy isoflavone supplement and I could be an equine producer, and my friend could take the same soy isoflavone supplement, but might not have those species that enables them to produce equal, this very strongly binding phytoestrogen. And the research shows that there was a 75% difference in terms of symptom burden. So I would get a great benefit, yet my friend wouldn't get a great benefit. And what this shows is the importance of individual variability. This demonstrates the importance of the microbiome. It also demonstrates the important role that the microbiome plays in also metabolizing estrogen, as well as the role that estrogen plays in terms of the microbiome.
And I think too that I recall that when the study came out, that there was also like one of the takeaways that was written in the paper was that the changes in the gut microbiome demonstrate why insulin sensitivity declines after menopause. I know you kind of alluded to that, but I just want to make sure that that's an accurate takeaway that I had.
So we looked at specific species in the pre and postmenopausal women, and the species that we saw that were elevated in the postmenopausal women are species that our previous research that we'd published a few years before in Nature Medicine had been associated with a greater likelihood of insulin resistance as well as other intermediary risk factors related to cardiovascular disease. So, whilst we can't say that it's a direct causal effect, because this is cross sectional data where we've just taken samples at one point in time, what it can tell us is there's something interesting going on here, that postmenopausal women have a greater prevalence of species that other research that we've published has shown to be associated with insulin resistance and other detrimental health measures as well.
Which doesn't need to be a doom and gloom situation. You know, we work with plenty of postmenopausal women who drastically improve their blood sugar response with dialing in their nutrition and, really implementing a lot of what you're talking about today with the changes that you have to have a heightened awareness around, I think, like even higher awareness around after menopause. Is that how you would explain it?
Yeah, so our research shows that postmenopausal women have a higher blood glucose response to a standard meal compared to a premenopausal woman. So if I was to have a piece of cake as a peri or postmenopausal woman, which I am, I'm 49 years old, I would on average have a higher glucose response compared to how I would have 10 years ago. Now, part of that could be due to age. So in our research, we actually took an age match group where we had people of the same age, some of who were peri and postmenopausal and some who were premenopausal. We even found in an age match group that the peri and postmenopausal women had a higher blood sugar response to a standard meal compared to the premenopausal women. And so, what that shows us is that if we are concerned about our post meal glucose response and going on that roller coaster, then I think we should be a bit more mindful about our blood sugar responses. I don't think we should cut out carbs at all, but I think that takes us back to something we talked about earlier. I think we should just be a bit more mindful about making sure that with those carbs, we're also having healthy sources of protein, healthy sources of fat, and adding fiber to them as well. So try and avoid just having carbs on its own, but it's more about what can I add in rather than taking that carb away.
And also something that we, will incorporate from recipes and things that I have in my membership are, like desserts that just have less added sugar, that are, made with different sweeteners. Not Although obviously at the end of the day, like a sweetener is a sweetener. Talking about like coconut sugar versus table sugar. And then, even like having some of it be made from almond flour and other things that I think, can then you still enjoy it. And then you know that you're not going to have the heightened blood sugar response. This is even like what we do for my kids that are 1 and 2 years old is that I mean, we've been trying to avoid added sugar until the age of 2, but, making some of those swaps so that it still feels like they're having pancakes and other things like that.
Yeah, absolutely. Look, I'm a great believer that if a food is too healthy to be enjoyed, it's just not healthy at all. That you've got to make sure that you enjoy that food. And, at the end of the day, on a Saturday morning, it's my pleasure to cook pancakes for my kids and put lashings of chocolate Nutella spread on it for the kids, I don't think that's going to do them any harm. Now, I know as a perimenopausal woman, that's going to cause me to have a bit of a dip in my glucose a little bit later and feel a bit rubbish. So what do? I still have it, but I try and make sure together with it, I'm having some fiber-rich fruit or so forth, or a bit of extra protein with it, like some nuts, for example, as well. But as well as what you can add on, the kind of swaps that you're suggesting, are great ideas. If that's something that someone can easily incorporate, absolutely. Don't not have that pancake. Just think of a different way of doing it, a different flour that you can use and so forth.
And then quickly, what is your take on some of the sweeteners that are out there since there's so many now? Do you feel like just simply swapping out sugar for stevia and monk fruit, like so many food manufacturers are doing right now, is there a potential downstream effect that people aren't thinking about from a gut microbiome standpoint?
So I think there's a couple of things to think about with sweeteners is firstly, actually just by swapping out sugar for sweeteners, are you actually just increasing your sweet desire? Because we know many sweeteners actually stimulate our sweet taste receptors more than actually sugar does. And so you're just becoming actually accustomed to having even more sugary tastes. The other factor is, yes, the gut microbiome. And there's some really interesting research coming out of a group in Israel, Erin Segal's group, that has done some randomized controlled trials looking at different sweeteners, feeding them to humans, feeding them to mice or rats, I can't remember which animal, apologies, and looking at how they impact the gut microbiome. What we know is that not all sweeteners are created equally, and I think that's really important. We know that some sweeteners seem to negatively impact our gut microbiome, where other sweeteners seem to not negatively impact our gut microbiome. I think we're still at quite early stages of the research to say this sweetener's safe and that sweetener's harmful. I think there's sufficient evidence to show that sucralose, ACE-K, aspartame, probably we don't really want to be having as a sweetener, and that they can negatively impact our gut microbiome. I think there's evidence to show that some of the more natural sweeteners like stevia don't seem to be impacting our gut microbiome. But I'm cautious to say we know for sure because I think it's something that we haven't done enough research on just yet.
That makes total sense. Dr. Sarah Berry, thank you so much for being here. Can you tell everyone where they can find your work and benefit from your expertise?
Absolutely. Well, thank you so much for having me and let me talk about all my favorite topics, particularly the food matrix. If you want to find out more about the kind of stuff we're doing, we do at Zoe have a podcast. It's called the Zoe Science Nutrition Podcast. I'm regularly on there as a guest talking about my own research or on there also as a host, interviewing other people alongside the co-host Jonathan Wolf. I'm also on Instagram. I don't know what my handle is because gosh, isn't that awful? I'm also on Instagram, and I think my handle's Dr. Sarah Berry, but put in Sarah Berry and you should be able to find me. And I also have a page at my university website, which is at King's College London, where for those geeks out there can actually get a list of all my publications, all my clinical trials, if you want to feast yourself on that.
I just looked, it's Dr. Sarah Berry, and Sarah is spelled with an H at the end.
Yes.
Just so that everyone knows, that's where they can find you on Instagram. But
Thank you.
if you are not a if that doesn't say that you're a researcher, I don't know what does. Thank you, Dr. Sarah Berry, for being a part of the Being Brigid Show. It has been such an honor. I've been so excited to have you on. So I really appreciate you spending this time and sharing your expertise with us. And I will see you all next time.